This is part 8 of the series Calculus Prerequisites, and we're going to start this part with a brief discussion of logarithms and logarithmic equations. Last time we looked at the properties of logarithms and we executed a few of them, and now we're going to do a couple of very simple logarithmic equations just to get you back to practice and working with logs. Now, a logarithmic function is very similar to an exponential function in that they're both one-to-one functions. So we can use the one-to-one property of logarithms to eliminate all the logs here because we have a log for each one of the terms. So that's one way to solve it. So x minus 2 equals 17, x equals 19. Now looking at the next problem here, we can see that we have only logs on one side. So we're going to have to do something slightly different. We don't have the one-to-one property any longer that we can take use of. But we do have a sum of two logs here. And the logs are with the same base. So let's combine these with the sum property. We have log of 8x. Log of 8 plus log of x is the log of 8 times x equals 1. And now we're going to use the principle that logarithms are exponentials, are exponents. Logs are exponents. This is an exponent. This 1 is an exponent. The base is 10. So the equivalent expression to this logarithm is simply 10 to the 1 equals 8x. And so that means that's all we have to do is divide both sides by 8. And x equals 10 divided by 8, which is 5/4. To summarize, the idea at work here is that the log of base A of some item B equals C. This logarithmic expression is equivalent to the base A to the exponent C, because logs are exponents, equals B. So these are equivalent inverse expressions. If this is true, then this is true. And likewise, if this is true, then this is true. All right, let's move on to the next problem down here. And again, we have logs on one side. Here we have the difference property being used, logs to the base 8. So we can say here log to the base 8 of x squared minus 1 over 3 equals 1. Now we can say the base is 8, so 8. Exponent is 1, so we don't really have to write it, but we'll write it up there just to show you what I'm doing. There's a 1 equals this guy, x squared minus 1 over 3. Now we just solve for x here, just like we would any other algebraic equation. Multiply both sides by 3. 24 equals x squared minus 1. Add 1, 25 equals x squared. And we have x equals plus or minus 5. Ordinarily, you'd have to check to make sure that both of these worked, but you can see that x is being squared, so whether it's positive 5 or negative 5, they're both going to work in here, and so you don't have to go any further. But it's always a good cross-check to go ahead and take your value, substitute it in for x, and make sure that this works, just to ensure that you've got the right answer. Now let's go ahead and work this last problem over here. So we have ln of 5 minus 2x plus ln of 9 equals 4. And this is the sum property. So this is ln. Multiplying 5 minus 2x times 9 gives us 45 minus 18x equals 4. And then we just take e to the 4 because the base ln is log to the base e, and so our base is e. So e to the 4, this is our exponent, equals 45 minus 18x. E to the 4 minus 45 equals negative 18x. Divide by negative 18. Divide both sides by negative 18. X equals this guy over here. Now this is the final form because e is an irrational number, so this doesn't simplify any further. I wouldn't go forward and get an approximation unless you're called upon to get the approximation to 3 or 4 decimal places or whatever it's asked for. But anyway, this is your final result. Now in the next part, next section, we're going to work on quadratics. We're going to go through solving quadratics by various methods. And we experience quadratics quite often in calculus, cubics and quadratics and other forms, but quadratics is our next piece. So let's look at that now. Now, we're going to look at solving quadratics by a couple of methods. First one is by factoring. So we take a look at this quadratic, and we know that since its highest order exponent is 2, this is made up of 2 linear factors. So we know that some linear factors are going to multiply together to give us this guy, and these factors have to multiply together to reproduce this quadratic. So this term has to be an A and this has to be an A. Now one of the techniques you can use here is to look at the signs. If this sign is negative, then you know that these signs are going to be opposite to each other. One's going to be positive, one's going to be negative. If this sign is positive, then these signs are both the same and they're going to take on whatever that sign is. Since this is negative, these are opposite signs. Doesn't matter which one we put where. So let's make one plus and one minus. Now we need factors of 51. They're going to give us 14. Now the only 2 factors that I'm aware of are going to be 3 and 17 and 51 and 1. Now there's no way I'm going to get 14 out of 51 and 1, but 17 and 3 would give us that if we had a positive 17 here and a negative 3 here. 17 minus 3 gives us 14. So let's see if that works. We have a squared minus 3a plus 17. That gives us our 14a and minus 51. So that works. Now that we have our factors, we're going to try and find the values of a. So because this factor times this factor equals 0, we're going to use the zero product rule, which means that if 2 values multiply together to give you 0, one of those 2 has to be 0. That's the only way you're going to get 0 on the other side. So let's assume for the sake of discussion that it's this term that's 0. So let's say a plus 17 equals 0. Solving for a equals negative 17. Now let's assume it's this one. A minus 3 equals 0, a equals 3. So our solutions are a equals 17, negative, and 3. Now we could have used the quadratic formula to get this. And if you forgot what that was, I'll give it to you real quick here. I'm not going to go through the whole thing, but you know that in general, your x value equals negative b plus or minus the square root of b squared minus 4ac, and that whole right side all over 2a. Now, the coefficient of your leading term, the squared term, that's your a. The linear term is your b value. The linear coefficient is your b value, and your constant is your c value. All right, let's move on to the next problem. First, we want to factor it to get our individual factors. So here we have 2 linear factors again. And this time we have a positive sign here, so both of these signs are going to be the same, and they're going to be that sign. So we have an x plus and an x plus. And we need factors of 8. They're going to add up to 6, so clearly that's 2 and 4. X squared plus 4x plus 2x, it gives us our 6x, plus 8. Again, using our zero product rule, x plus 2 equals 0. Therefore, x is going to be negative 2. X plus 4 equals 0, so x is going to equal negative 4. So x equals negative 2, negative 4. Let's move up to here. X and x. It's a positive again, but this sign is negative. So both of these are the same and they're negative. And here we need factors of 11 that add up to 12. Well, that's obviously going to be 11 and 1. These are pretty easy. So our two factors are x minus 11, x plus 1, which makes the first one x equals 11, and the second one x equals 1. So x is 11 and 1. And now for the last one. It's negative, so they're plus and minus. And it's a 3, so it's going to be 3 and 1. And since this value is negative, let's put the 3 negative over here. 3 and 1, n squared minus 3n plus 1n gives us our negative 2n minus 3. So there we go. So n equals negative 1, n equals 3. Now just for kicks and giggles, let's go ahead and use the quadratic formula to verify our results here. We know that it's negative b, so since b is negative 2, it's going to be 2 plus or minus the square root of b squared, negative 2 squared is 4, minus 4 times a is 1, times c is negative 3, and that whole thing over 2a. And since a is 1, it's just 2. So this is actually x equals that. Now let's calculate the discriminant first. This part underneath the radical in the quadratic formula, that's called the discriminant. And so what we'll do, we'll put it up here at this point. So x equals 2 plus or minus the square root. So here we have negative 4 times negative 3 is positive 12. Positive 12 plus 4 is 16. All over 2. So that gives us 4 up there. So that's 2 plus or minus 4 over 2. And let's look at our different pieces. 2 plus 4 is 6. 6 divided by 2 is 3. And 2 minus 4 is negative 2. Divided by 2 is negative 1. And so using quadratic formula, we get the exact same values. Now, sometimes you'll be asked to explicitly factor something because it'll be essential to have the factors. But it's up to you in general. When you get to this a problem like this in calculus where you're just looking for the solution of a quadratic, then your best bet is just to use the one that's quickest for you. If it's quicker to factor, go for it. If it's quicker to use quadratic formula, do that. If it's quicker to complete the square, do that. And we're going to do completing the square next. Now, this is going to be a little bit more involved process, so we're going to start that in the next video. So I will talk to you in the next video.